Phison's CEO just said that many consumer electronics manufacturers will go bankrupt or exit product lines by the end of 2026 due to the AI memory crisis, and that DRAM and NAND shortages will extend beyond 2030, citing industry structural shift that will destroy consumer businesses. And we've got lots of other great news to report on today as well. There'll be timestamps if I have time to do them down below to find them. And if I don't have time, maybe somebody in the comments will. Anyway, let's talk about this. So this is the CEO of Phison, and it's a grim picture that he's painting. Essentially, he's saying that if you can't actually source a single part that you need to make your to manufacture your electronics that you sell, you can't make anything. So having something hung up like the memory just means you're out of luck. You can no longer continue in your business. We could look at some direct quotes on this. So foundries are demanding 3 years of prepaid payment, unprecedented in the electronics industry, with the sellers market at an all-time high. Internal estimates from foundries suggest shortages will persist until 2030 or even potentially for a decade, with no end in sight. This is the CEO of Phison, so he knows more about the inside dealings of all of this than I do. So the basic idea here is, again, you cannot make a product if you're missing any of the components. Another direct quote, from year end to 2026, many system companies will shut down or exit product lines due to inability to secure memory. In the second half of 2026, large numbers of low-margin brands will exit. Low-end products will disappear, creating a market vacuum until supply recovers and growth explodes again. This is painting a really grim picture, but I totally see where he's coming from. If AI companies are able to buy years' worth of contracts for memory, that's what the other companies are competing with. And if AI companies are just still getting massive amounts of investment money that they can throw at this kind of thing, then they can do that. So if you're the one selling the memory, why would you take somebody else's deal if this company's offering you 3 years of prepaid payment? Why would you turn that down? Because maybe it's going to destroy the rest of the tech, industry? Well, I mean, okay, but the company wants the money and they're going to get the money. So that's where we're at. This is just a terrible place for the industry to be in. I don't really know what to say. It affects graphics cards, it affects computers in general, trying to build the memory, but it goes beyond that. Memory is used in so much stuff now. We're talking not just TVs and smartphones, but even some refrigerators, right? So much stuff uses memory that I think this is going to be pretty scary what the effect has. Because yes, prices go up, that's one thing, but if there's also just simply less supply than what the companies want to buy, and the AI companies can just make these huge prepaid contracts, how do you compete with that? The other businesses probably don't have 3 years of cash on hand, to compete with that kind of offer. So we're already seeing things like this happening in the market. You cannot buy a Steam Deck OLED right now. This is confirmed by Valve that it's specifically due to the memory and storage shortage. Now, they could probably pay some insane price to get it, but then they can't sell at the price that they want to or that they think customers will pay. There's now a note on the Steam Deck page from Valve saying, note, Steam Deck OLED may be out of stock intermittently in some regions due to memory and storage shortages. Steam Deck LCD 256GB is no longer in production, and once sold out, will no longer be available. Notice this lowest end model is just no longer in production, and that's one of the things that this Phison CEO was mentioning here, is that the lower end products and lower margin products could just exit the market, right? Large numbers of low margin brands will exit. Low end products will disappear. If companies can only supply so much memory, then they are going to focus it on the products that can generate the most revenue, the most margin for them. And also, if they just cannot offer a cheap product anymore, then all they have left to offer is the more expensive products. And we're seeing that here where the lower end Steam Deck gone, and the higher end OLED model will be out of stock intermittently due to this, but like it's out of stock, guys. Now, how about the Steam Deck competition? You can still buy an ROG Xbox Ally X. Its price in Japan has gone up 21%, and Legion Go 2 prices are climbing in the United States. I'm finding this at videocards.com. It looks like they're sourcing it from Automaton. By the way, all my sources will be linked in the video description as usual, so you can follow this up in more detail for yourself. We're also seeing this hitting Sony. Now, Sony doesn't want to increase their PlayStation 5 hardware cost because they want to keep selling them. Now, maybe they'll have to, but their plan to minimize PlayStation 5 hardware price increases is reportedly to focus on monetizing the existing installed base. And I've got to say, that sounds like bad news for the installed base. I would imagine they're probably bouncing around things like increasing the price of subscription services. We saw Game Pass price skyrocket recently. Now, they try to bundle in some other features along with that, but if you don't actually use or care about those additional features, it was just a massive price increase. So it would not at all surprise me if Sony would increase the price of their subscription services in order to try to make up for a loss, or at least less margin on their hardware. Keep in mind that the console business model for many years has always been to even sell hardware at a loss, at least initially, and then to recoup that money and then some in the software sales. And then later it came out into the subscription services and all of that. But it seems like this more recent generation, Sony and Xbox, and I think as has always been the case for Nintendo, they've been less wanting to take a loss on the initial hardware sale. And so this kind of looks like, prices are going up. They don't really want to take those losses, but if they have to, they're going to try to find that money. And that's from you if you own a PlayStation. So that doesn't sound like good news. Also, are we going to get the next PlayStation? Because if it launches at too high of a price, will people pay for it? But they're not going to want to take some massive loss. So we're once again seeing increasing numbers of rumors that the PlayStation console for PS6 would be delayed until 2028 or even 2029 because of the tighter memory supply and price. Now, is even that going to be enough? Because like we heard from the Phison CEO, that they're expecting that the shortages will persist until 2030 or even potentially for a decade with no end in sight. Now, a lot of people are waiting for that, AI bubble to pop, and maybe it'll pop. But we don't know. We still don't technically know if AI is exactly a bubble, or if it is, what exactly that looks like. We don't know. You can't predict these things. You can't actually mathematically know you're in a bubble until the bubble has popped. So will it? When? Is it a bubble? We still don't know these things. A lot of people want it to be. I think some elements of AI technology have proven to be useful, some more so than others. There's still questions on how do they actually monetize that? How do they make up the money? Are the profits there? We've seen some stock prices going down, but that doesn't necessarily mean this whole thing just collapses. We'll have to see. I don't know. But we are also seeing that the PlayStation 6, whenever we do end up getting it, might not actually have the full RDNA 5 feature set. Now, first of all, this is coming from the leaks and rumors side of things. This one specifically is coming from Kepler L2. Now, Kepler L2 has leaked accurate information about AMD hardware and Sony PlayStation hardware specifically. I think he was one of the first ones with some of the PS5 Pro leaks, for example, which did end up panning out as accurate. So Kepler L2 may know some things, but could also just be a knowledgeable person speculating, so it's always important to keep that in mind. But he's saying that PS6 won't include the full RDNA 5 feature set. Now, I think that again, stands to reason. For example, the PlayStation 5 doesn't actually have the full RDNA 2 feature set. It's more like RDNA 1.5, where it has some elements, but not all of them from RDNA 2. So it's very likely that Sony, to keep costs as under control as possible, are just going to be looking to pick and choose which elements of RDNA 5 they feel like are most cost effective to what they want to do with the console. Now, we already know what they want to do with the console. We've had discussions of Project Amethyst openly from Sony's Mark Cerny, talking about the big features being neural arrays, which were a collection of compute units that are configured to share and process data working together as if they were a single AI engine. Radiance cores, new dedicated hardware for ray traversal to deliver high-performance real-time ray tracing and path tracing, and universal compression, which is a system that evaluates and compresses all available GPU data to dramatically reduce memory bandwidth usage. So now a lot of this is really interesting. For example, in some of the leaked specs we have for the PS6, it does seem like it'll have more memory bandwidth than the PS5, but not necessarily like a massively higher generational increase. But if you could compress all of the data on the GPU, then that you're effectively making much greater use of the memory bandwidth that you have. So you effectively have more memory bandwidth if this ends up working out well, right? So that's cool. And then these two things, the neural arrays and the radiance cores, essentially are, I think, Sony saying that they're agreeing with the direction Nvidia took hardware, where it's all about using AI upscaling and ray tracing, path tracing being the future of rendering graphics in video games. So that seems to be the way they're going, which has influenced their research partnership with AMD on their designs for things like RDNA 5. But it's looking like they might not take the full feature set into the PlayStation 6 if we believe Kepler L2. Now, in other Sony PlayStation-related news, this just broke a couple hours before me filming this. We're seeing that PlayStation is shutting down Bluepoint Games. This was the studio that had been doing remakes like Demon's Souls and Shadows of Colossus. Now, this is horrible news to hear another studio getting shut down. This is coming from Jason Schreier. And again, all my sources will be linked in the video description. He's saying that this impacts 70 employees, which is rough. Now, this also ties into, I did a recent video talking about how companies invest in live service titles. That you're essentially making a bunch of bets and you hope all of them pay off, but you expect actually half or more of them may just fail. But if the live service game, if one of them takes off, or multiple hopefully, but certainly not all of them, take off big enough, it could be such a big revenue generator that it justifies all of the bets. Now, while mathematically that model can make sense if you do actually bet on things that could indeed succeed, so there's that question mark. The real downside to all of this there's a human cost to this. Studios getting shut down. And that is what happened to Bluepoint. So Sony absolutely made a bunch of live service bets a number of years ago. They had a big push to start developing tons of live service titles all at the same time. And of course, they wanted to develop all of them in ways that could theoretically win. Concord was famously one of those, and that one certainly didn't pay off on its massive investment. However, Bluepoint was working on a God of War live service title, which was then canceled and shut down before it even released. So if a company is making this kind of investment strategy where they make a bunch of bets on live service, they're going to instantly pull back funding the second they're sure it's not going to blow up. That's what they're going to do. So if this game was already at a point in development where they were pretty sure it wasn't going to pay off on the investment, they pulled the plug right there. The problem is, that happened early last year, which means that Bluepoint has now been trying to pitch ideas for what they could work on next, and Sony apparently wasn't happy enough with any of those, didn't think it would pay off investment-wise, and are shutting down the studio. So yeah, now we've seen again Sony carrying out with the same live service ideas, right? They've got, I'm pretty sure Sony owns Bungie, who's about to release Marathon, and then they also, they have Helldivers 2. There's the new Horizon, what is it? Horizon Gatherers or Hunters and Gatherers? I don't even remember. There's that Horizon live service title coming out. Isn't there like a second Horizon live service game also in development? So yeah, Sony absolutely was taking the make a bunch of live service investments, cancel anything that doesn't work, hope one of those investments pays off big enough to pay for everything else. But sorry to the studios at Bluepoint that weren't one of the lucky ones. So that's what happened to Bluepoint, and I hate to see it. Now, there is still a bunch of God of War stuff coming from Sony, including a God of War Trilogy remake. And we're now getting some additional information. It is looking like it's not going to be like a straight like remake, but with the original gameplay. We're hearing that it will feature a new combat system. Now, this is coming from Christopher Judge, who was a Kratos voice actor in the more recent God of War titles. I think we're also hearing that Judge won't be the voice in this remake, that the actor who played Kratos in those original games will actually reprise the role. That's T.C. Carson. So, interesting information on that. Hey, maybe Bluepoint, who was good at remastering or remaking old games, could have been working on this instead of a live service title, which wasn't what that studio was good at in the first place, Sony. But anyway, whatever. Now, this is interesting. So with DLSS, really changing the way a lot of people use rendering. Like, it used to be the case that rendering a game below your monitor's native resolution was a disaster. It would just look terrible on your screen. But with AI upscalers, starting with DLSS 2.0, and then we keep getting updates and updates and updates, it's gotten to the point where DLSS was always marketed as of 2.0 as better than native. And in really certain specific situations, it was, but in many situations, it wasn't. And I would argue that's still the case, where there are obviously places where it is not better than native. However, Computer Base has just done a really interesting test, which is a blind test of, do you prefer the image from DLSS 4.5, FSR 4, or native rendering plus TAA? Now, I know some people are going to be like, well, they put TAA on that, so blah, 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 blah. Well, guys, that's how modern games do anti-aliasing before you had options like DLSS and FSR. So it's if we didn't have this AI upscaling business, TAA is the anti-aliasing of choice by game developers for deferred rendering, which is the way that we do rendering. So anyway, so that's what we've got. Now, the really interesting thing here isn't that there was a massive preference of DLSS 4.5 over FSR. What's interesting is that DLSS 4.5 was also preferred over native TAA in a blind test. Now, I should clarify, blind test does not mean blind people were asked, because that would not be the right population or way to do this study when you're judging image quality. So to be clear, people were shown the image and then asked which they preferred without knowing which was which. That was hidden. And they studied a lot of people in a number of games. And the games involved were Anno 117, Arc Raiders, Cyberpunk 2077, Horizon Forbidden West, Satisfactory, and Last of Us Part 2. And they have their table of results here. Again, source will be in the video description. I'm machine learning translating this. This source is a German language publication. Now check this out. So overall, game by game, we have, again, native is losing pretty dramatically to DLSS 4.5. FSR was sometimes chosen as the favorite, and even over native, but native was chosen more often than FSR. So we would not say that FSR is better than native in a blind test. However, DLSS 4.5 was preferred in a blind test pretty dramatically compared to native rendering plus TAA in every game. The only game where it was even close here seems to be Cyberpunk. So that is very interesting. The overall final result totaled up is that in about half of cases, the most preferred response was DLSS 4.5. And native came in second at 24%, and FSR came in third at 15%. That's pretty crazy. Like, I think that this is objective testing saying that most people prefer DLSS to native now. Now, that being said, I don't think that this is a completely perfect or completely representative test. I think it is very, very good. I'm not trying to say they did anything wrong. I will say the tests that they showed all did a very certain type of camera motion, which is different than character motion. And also there are certain other like pain points with upscaling that weren't necessarily represented directly by these types of tests, right? So if you're doing image quality testing of upscalers versus each other or versus native, there are certain elements of the of rendering that are harder for upscalers to handle. And so I'm not sure when I looked at the footage that I feel like it completely was representative of all of the types of situations that you would see while gaming, but I still think it was a fantastic test. Also, one more thing is my reading of this is they're using quality level upscaling. And I do think that that is not necessarily the way you would always use this. So more aggressive upscaling settings might also be something that would be neat to test. For example, okay, DLSS 4.5 quality was preferred over native. What about DLSS 4.5 performance mode? Would that be preferred over native? But in and of itself, this is a pretty interesting test, and it had a lot of user responses, blind testing, and the DLSS was preferred at about twice the rate over native rendering by the respondents. Now, this also means that there were people who preferred native and people who preferred FSR over DLSS. But in a blind test, there's a lot of evidence now that DLSS is now preferable to native rendering to a large portion of the gaming population, even if you disagree. There's also been some really interesting testing happening with absurdly low rendering resolutions for DLSS. I found this at videocards.com, but they're referencing testing done by 2Clicks Phillips in this video that says, titled DLSS is magic, and this proves it. So what this is doing is looking at, so what's really happening? So if you have a 38 by 22 image upscaled to 4K, okay, that's going to look pretty bad, right? But once you get up to like 160 by 96, which is 4% of 4K, you're starting to at least get a somewhat recognizable image, right? So this is really interesting because if you look at what an actual like 136 by 76 image is, and yet you look at DLSS producing this image on the right, it's kind of insane. It doesn't seem like that's possible. So when we're getting into, but how could an upscaler, which is rendering at a lower resolution, how could it ever actually be better than rendering at a higher resolution? And the reason is it's using more than one frame of data. So does TAA. That's the whole temporal idea. You're using previous frames to inform what's happening in your current frame. And then there's some jitter, so you get different elements of the screen in each of those frames. So you're taking multiple images that are blurry like this and then compositing that temporally into a more detailed image. So if you have enough data and you put it together in an intelligent enough way, basically, if DLSS 4.5 is better than native TAA, what we're saying is that it can work because it's a more intelligent algorithm and a more compute-heavy algorithm, potentially, that you can take multiple native images but then use TAA to try to put together an image, or you could use the same amount of images at a lower resolution, but use a more intelligent way of putting them together, and that you end up with a better final result than the native rendering. So that's how could you ever render it lower than native and output better than native? Because the native res is using a less intelligent algorithm. So that's where we're seeming to be at least by public opinion when looking at the images. Not that it's always better in every case, right? So now, it's not better than native in the sense that if you compared DLAA, native resolution, to DLSS quality, you're probably always going to have a better image with the native image if you're applying the same upscaling algorithm to it, right? But it's basically just that the way it's temporally taking that data and reconstructing is getting so much smarter than TAA that you can have less resolution to work with, but still end up with a better final result. And it's interesting to see at extreme low resolutions how that can put together at least a recognizable image doing extreme testing like that. I think it's pretty interesting. Now, on another note, how about AMD's new desktop CPUs? So Zen 6, codenamed Olympic Ridge, Ryzen desktop CPUs may be coming in 6-core, 8-core, that's not surprising, 10-core, 12-core, 16-core, 20-core, 24-core. Okay, some of those are core counts that we're not used to. Now, where is this coming from? We've already had rumors like this coming, over time from various sources. The latest one is from HXL. I found this at videocards.com. Again, sources in the video description. And okay, this is one of those tweets where it's like, okay, 6, 8, 10, 12, 8 plus 8, 10 plus 10, 12 plus 12. So maybe HXL is doing some like elementary school math and basic pattern recognition, or because it's a hardware leaker type account, more likely they're talking about the AMD CPU cores. Now, basically, it's looking like you're going to be able to have more CPU cores per tile. So AMD had CCDs, which in up to the previous or like current generation, I should say, you could have up to 8 cores on a tile, and then you could have 2 8 cores to make 16 cores, and that's like the limit on your consumer CPUs. But then you have like Threadrippers and stuff that could have even more tiles on it. But the idea is that each tile can now go up to 12 with Zen 6, which would mean you could now have 12 on the same CCD, rather than previously we used to get 12 by doing 6 plus 6. And now you'll be able to go up to 24 because you're doing 2 12-core CCDs, but we could also see things like 10, because 10 is going to be possible now if 2 of your cores are disabled. Then you would have 10, but then you could also do 10 plus 10 and get 20. So we'd get some different core count configurations possible incoming with this generation. But again, to be clear, this is all still in leaks and rumors, but is pretty consistent with other leaks and rumors that we've been hearing. Another kind of leak, it's really, not like a leaker just posts stuff on Twitter. This has more to do with looking at GitHub on looking at the code there. And the types of, man, I can't speak, guys. The types of instructions that are available here, like FP8 instructions. Now, why would this be interesting? Well, we're talking about what looks to be an iGPU. So like RDNA 4 is where we got FP8 instructions. So a mobile 4M iGPU with FP8 instructions could support FSR4. FSR4 famously needs FP8, although there was that int8 version that's been leaked, which does run on older architectures, but AMD just refuses to actually put out, apparently. Hopefully it's still coming at some point. So I've been heavily critical of AMD's mobile lineup, iGPUs not getting updated to RDNA 4, still using RDNA 3.5, and therefore not supporting FSR 4. It's one of the main reasons why I haven't bought a more powerful AMD gaming handheld since my Steam Deck OLED, because it feels like a waste to buy into technology that doesn't support modern upscaling, especially if you're on extremely power-constrained hardware. So, you're often having to use upscaling. I'd like it to look as good as possible. So anyway, it's looking like when we get to Ryzen 500 Medusa, we could be getting RDNA 4M iGPUs. with FSR for support. But again, that's not AMD claiming it. We're just looking at like code backend stuff being merged on GitHub. So there you go. Now, in other AMD news, an AMD GPU, specifically a Radeon RX 9060 XT, has broken a GPU frequency world record at 4.769, which is nice, gigahertz. An RTX 5090 has burned up again. I am almost sick of reporting on these, and it's the connector, to be clear, once again. But what's more interesting is that this user has actually intentionally power limited the GPU at 500 watts, theoretically to avoid this kind of problem. Didn't work, still burned. Are we still using these connectors next gen? Obviously, it's a small percentage that seems to be having these issues, but I don't know. Kind of seems like a problem, guys. Anyway, now at GTC, Nvidia's CEO will apparently be unveiling chips that the world has never seen before. And if you're hoping it is some exciting new gaming product, we all know it's going to be AI. Anyway, that's what I've got for you guys today. Hope you found the video useful and or interesting, and you all have an excellent day.